Friends, today I have this problem in the clock. Here it is, prayer time indicator. Here it is clock. It gives time, 24 hours. Here the date. Here is 5 prayer times. 5 prayer times. And here it is after athan, what is time for prayer. It is downtime counter. These are fixed indicators. When it will work, it have now fault. It is flashing. What is inside this? Here we have 5 volt power supply. It is buck converter. Here I have 220 volts. I will show you in detail. We can see here, I will switch it on. First I will show you the procedure how you can check this one. If I see here, here is AC volt. I set AC volt and I will check the input. It is giving me 232 volts. Now I will check the output. This one is input of the circuit. Here it is a chopper circuit, converter circuit. First it will make AC to DC, and then here we have output 5 volt. It is TTL, transistor logic. TTL output 5 volt. I connected this. Sorry. If we see, it have fluctuation in power. It have fluctuation in power. The power is not stable. The input power, we have problem in power. Here it is PIC microcontroller. It is a timer. It have a built-in battery 3 volts which applies power to the timer circuit. If the main power goes out, the circuit will not lose the time. So timer circuit will continue working. When the power arrives, the main display will on, but without power, this backup battery, it will apply the voltage to the circuit. Now I will see what is the reason for this voltage down. First I will, and moreover, if we see all segments are connected in parallel with Ethernet cable. If you see, this one is connected, it is same line. All segments are connected in one line. It is Ethernet connection. This is main input, and every segment have its own address. We can say this one is address 01, 11, 10, 02, 03, any one address. This microcontroller addresses with the help of address number, the location number. If you want to write, suppose address number 07, suppose. So he will send command, all will receive the command, and only number 7 will accept the command, other will remain silent. Meanwhile, if he anytime want to send command to segment number, suppose this one, this board, number 1, number 2, number 3, or any LED, so it will communicate in the packet data location number, that segment number 1, segment number 2, 7 segment displays. So all have power. This time I have the main problem in power, because if we see, the main issue is with power. I have to hold with camera and we can see the power have problem. Now I will apply external power. I adjusted my external power and here it is 5 volt. I will increase 5.1 volt for, okay, 5 volt, that's good. What I will do, I will put this 5 volt here, and the same time I will remove this connection from here, 5 volt positive, and I will remove in the working condition, so we can verify the problem is power or where is the problem. Yes, I removed this one. This one is positive, this one is positive, and this one is negative. If you go to board, you can check, here is VCC and black one is ground. When you apply positive voltage and negative voltage to any DC circuit, must care for the polarity. First I will connect the power to the circuit and we will see the response on multimeter. When we connected the main power here, the multimeter was fluctuation. It was fluctuating. So now I am going to connect. So take care friends, if there is any blast or any smoke, don't worry, because it is my routine job. So now I connected, just it is a joke. You can check now the problem, even problem in power or any one segment. So here we can see, here the power is stable. Now the power stable. And if you see, oh, that's great. It is our fault finding technique. You can find the problem. How we detected the fault. Where is the problem? Problem is here. When I connected power here, external power, this one, this wire is bringing external power. I disconnected this one. Okay, now if we see the power, it have a very big fluctuation. It should be fixed voltage. It have fluctuation. When the fluctuation, the system will not work perfectly. Now we will check what is the bad with the power. I will connect again to verify the power, positive line, and I will connect the negative line. Where is the black lead? Oh friends, now I will connect and you can see first it will become reset every segment, and now there is no fluctuation. If I connect the original power, it makes fluctuation. We can see it is showing me 1.5, 1 past 35 minutes, and it is 10 August. Okay friends, now I will remove this one, this module. If we see this capacitor, I will make close view. If we see this capacitor, is plain, but if we see this capacitor is heat up, it have some surface raised up. We see this one is plain, but this it have some raise up. So this one have problem. I will remove this now, and we will check the problem. Here is specification for this board. This not for capacitor, this one is for board. It is giving model 1W10 top 5M. It is input 9 volt to 265 volt, very big range, very wide range, and the DC output of this circuit card, this module, this converter, it have 5 volts, 2 ampere, 5 volt 2 ampere. So this sticker for the specification of the board, not for capacitor. The capacitor is 400 volt to 22 microfarad. So if we see the circuit, here I have input connector, AC input connector. After AC input connector, there is a fuse. Okay, after fuse there is a filter, RC filter, capacitor, and this inductor, 2-line inductor. After inductor there is a bridge rectifier. After bridge rectifier there is a capacitor. After capacitor, this voltage go to the chopper transformer and this FET. Here is a converter circuit, oscillator circuit. This oscillator circuit makes oscillation at a specific frequency. This is pulse width modulator circuit, and this is optocoupler. I have uploaded a video for optocoupler. This is a feedback circuit. If the next circuit is good, it will give okay feedback. But this time we have problem in regulation. I will remove this capacitor and we will check this capacitor, what is the problem with this. So let's start our practical section now. I will remove this now here. I will put aside. Oh, this time I am arranging power. Now I will connect. Now I connected power supply here. Now I will check voltage. AC voltage at the input connector. It is 228 volts. Okay, if I check the output of the circuit is DC voltage. Here we see it is fluctuating. It have fluctuation. Now we will check the main capacitor. There should be DC voltage. This line and this line for capacitor. This and this. Now I will check here DC voltage. Here is DC voltage. So at this point, so input stage is perfect. It have 330 volt. The problem in output stage. So if I check the output capacitor, this point is the output capacitor. It have fluctuation. So fluctuation, as I told, the capacitor if we put this capacitor like this, if we see here from one side there is a swelling. This one is plain. It is perfect. Problem, the output capacitor or the regulator. Here is regulator, 5 volt regulator, I think. No, it is back-to-back diode, full wave rectifier. So problem this capacitor might be because it is connected directly to the output terminal. Yes, from here it is connected to output. So friends, we will check now this temperature setting for the desoldering gun. This is desoldering gun. Here is the soldering iron. Okay, I set the temperature 438 degree for this one. I have a button here. When I will press this button, the tip will heat up and it will pull all the solder in the chamber, this glass chamber, and all solder will come here. Now I will demonstrate. First, it should have the temperature, fixed temperature at this one, and now I will bring the solder wire. When you are working on any power supply, first of all, the main capacitor, this is the main capacitor, main DC capacitor, must short. Remove power cable and make short. Why? Sometimes it have a charge, it hold the charge, so sometimes it can make a very bad shock. Now I am going to clean this one. Okay, now I have to remove this capacitor, this output capacitor which have swelling. I will put on the, just 1 minute. Oh yes. Now apply some solder and heat it up and then press the button. It will everything. Now again heat up and now I can remove. When you remove, must take care for polarity. This white line for negative side. Okay, now I can remove this capacitor now. Because it was stuck with this material, with silicone. So now I removed capacitor. Now I will go again to our multimeter for capacitance to check the capacitor. Okay, now this capacitor have 100 microfarad 10 volts, 100 microfarad 10 volt. If we come to our multimeter, I have capacitor here. This time it is in ohm mode. To go to capacitor mode, we have yellow line, yellow indication, yellow symbol. For yellow symbol, press this one. Now it is NF, nanofarad mode. I will put my solder wire here behind the multimeter to show you a good image. Bismillahirrahmanirrahim. يعطيك العافية. يعطيك ألف عافية وكل عام وأنتم بخير. It is giving 1.79 microfarad. It is 100 microfarad. it should be 100 microfarad, and it is giving 1.7. so this one is short. If I check the continuity, it will not give continuity, but when you check capacitance, it will give a very bad result. I have analog capacitance meter, so this time I will not. Friends, this one, this capacitor is 1000 microfarad, 10 volt, and the same I have here, 1000 microvolt and 10 volt. Size is different, doesn't matter if I see the size, because I think it has some problem in growth. This is tall and this is small, but the specifications are same. So I will remove this capacitor, we will check, and we will use in the other board. I will press this button. We can see I removed from solder from here, and it is plain now, and I have this capacitor now. We will again check with the capacitance meter. Bismillahirrahmanirrahim. To check with capacitance, we first have to make short, and then I am going to check. It is giving me 569. Now it is giving me 1133 microfarad. It means this capacitor is perfect. This capacitor is very best quality. So if I come again to this capacitor, this is giving me 1 microfarad. So that means it have problem. It is giving me 1.4 microfarad, while this one is giving no good connection. No. It is giving me 1120 microfarad. So now I will connect this one here. Yes. When you will connect, always be careful for the polarity, because polarity of the capacitor is a very big issue in polar capacitors. If we see here, this one is negative side, and on the board there is also negative sign. When we were removing, I told you careful for the polarity. So now I installed this one. It is now here. How I detected? I detected it visually. When I see the board, power supply board, it was we can say there was a swelling. If you see this wire, this is like a rope, but this wire is the best soldering wire. It is American and it is resin filled in, flux inside, soldering paste inside. And if you see the soldering, it is better than this soldering wire. It will have a very good shine. If you see the shine in the joints, solder, still it is not cleaned because I have to clean this one. Without cleaning, if you see the shining, the other joints and this joint is very shiny. When the joint is shiny, so that means you have a very good connection. Very good. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. And now we will check the result. Either problem in. So now I will set multimeter to DC voltage, and I will check. Still we have fluctuation. So first problem we solved. The next problem, we have some other problem. We will see now. It have still fluctuation, but now the fluctuation is decreased. After replacing this, I have still fluctuation. If I check from this capacitor is taking voltage from this rectifier. Now I will remove this rectifier. This is full wave rectifier diode, this one. Okay, now I will remove this. Now we will check this one. This YG802C04, this full wave rectifier. This 0.1 volt. We have to replace this one. It means we have fluctuation from here. Here must be stable voltage, so we will check optocoupler. Friends, I am sorry. While I was working, I don't know how my camera was paused. When I removed a capacitor, and after that I removed this full wave rectifier, it was short circuit. And other thing I found is optocoupler open circuit in the output. Input was okay. The output circuit, output transistor of this optocoupler was open. Even if there is voltage available, it makes fluctuation. So I find 3 component bad in this watch. Now it is working. As we see in the first, these were blinking and no display. Now it is perfect, it is working. It have fully controls. The controls are backside. I am pressing the control. Yes, now it is in setting mode. We can see it is increasing. We are changing the date, time, everything. So it is now okay. When this time, current time will match with any of this, it will start a countdown for Iqamat as-Salat. So when this, okay, everything, it will give our countdown timer here. It is clock here, clock and date. This is Salat al-Fajr, Ashruk. This is sunrise time, Az-Zuhr, Salat al-Asr, Asr, Al-Maghrib, Isha. Friends, these three components I found bad. This capacitor, it was swelling here, it was short circuit inside, it was heat up. So this was the reason. This short circuit, this make short to this rectifier, and also a feedback loop. Maybe there was some voltage spike, high voltage, that was the reason for damaging this circuit. So now I have, this light is working. We can see I have set the time 4:22 p.m. It is 4:22. When this time match with this time, this countdown timer will start. Now we have 10 minutes to the Iqamat al-Salat. So if we see 4:22, here it is countdown timer 10, 9, 8, 1, 2, and at that time it will, when it is 0, countdown timer 0, it will stable. Now it is flashing. That means now it is time. Now it is 9. That means this time was matching. Now this time 4:23 and 4:22, now the time have difference. 4:23, 4:22, when this time and this time will match, this time will match with anyone, that will start countdown timer.